Well, hello friends. Welcome back to browser hacking. Today we are going to take a look at the performance.now thing. So let's bring up Firefox here and just demonstrate what it should do. So there is a performance object that gives you, I think it's a high resolution timestamp with the number of milliseconds since the page loaded or something like that. I'm not exactly sure, but this is something that you can use for any kind of performance measurements in web pages, and it's quite commonly used on the web. Perhaps not in user-facing scripts, but like internally, web pages like to use this to track performance metrics and stuff. So I think it would be good if our browser engine would support this. So I guess first thing we'll do is we'll just look up the spec for it. Okay, so performance now returns a DOM high-res timestamp in milliseconds. Okay, and that's just a double. Okay, and take me to the spec. Okay, so we need a performance interface that has this layout. So we'll start by just adding this kind of IDL. I'm just thinking, where does this go? Does this go on the DOM or is this its own thing? I mean, it's kind of its own spec. HR time. Maybe we should make its own thing for it. Okay, I should not have touched that. I should have McDeared it. I've been trying to make like subdirectories in libweb for different specs. So we have like CSS for CSS specs, DOM for DOM specs, HTML for HTML specs, but also stuff like UI events for the UI events spec. And now I'm adding high resolution time for the high resolution time spec. I think if we sort of try to keep the directory structure of libweb similar to the way that the various web technology specs are laid out, I feel like that sort of promotes this passive cohesion of the whole thing. Anyway, let's just plow forward. So then in that directory, we'll add a performance object, CPP and H, and I guess also IDL. So we'll start with just the performance object. I don't know what other interfaces exist in this spec actually. Performance interface. And this is a type def. So our IDL parser does not handle type defs right now. It's probably something we should add. There are many things we should add to the IDL parser, but I think we're good to go with what we have right now. So performance IDL. So we'll start by just declaring this interface. Event target, same way that they're doing here, except since we don't have a type def, we'll just say double now. And read only attribute. Oh, you know what? Let's just start with only now. All right, and I almost forgot to add everything to the CMake file. High resolution time. I guess that has to be up here, right? I get confused about like alphabetical order when there's a case difference between two things. Silly little thing, I know, but yeah. Uppercase goes first. And then we need to add this wrapper here. So web JS wrapper, high resolution time, performance. Okay, yeah, so we didn't make any performance object yet. That's why things failing. Okay, so let's start by sketching out the performance object. High resolution time. So I guess there's one performance object per window object because it's global in the window or worker global scope, right? Global scope pay, I didn't say. Window or worker global scope. Right, so you have a performance attribute on the global object. Which means I think we'll hang this guy off of the DOM window object, but more on that later. So first thing is we need a constructor, a destructor, and a double now. And then it needs to keep track of, because you notice when we ran this that it was like the number of milliseconds since the page loaded, so we need to keep track of, we need some kind of timer that keeps track of when the page loaded, so I think we'll just use an elapsed timer from libcore, because that's exactly what he does. He just tracks the number of milliseconds since you started it. Elapsed timer. I mean, yeah, maybe that's okay. Because internally it tracks the start time. Right. Yeah, this will be good. We'll call it timer. And this guy can just say mtimer elapsed. Okay. So far so good. And then in performance CPP, slap a license in there and include our header. Put the right names spec. So let's see, how do we get this thing to talk to the document and know when we started loading? I guess we'll instantiate this early. So document will, let's see, document creates a window object. Right. So this is the C++ side of the JavaScript global object. It's represented on the C++ side by a DOM window object. And I think we'll put the performance object in here because that sort of maps to how things are laid out in JavaScript land. So we'll just have a high resolution time, performance. Yeah, and we can even include it here. Or you know what? Let's not pollute the header more than what's necessary. Namespace web high resolution time class performance. Okay. At the same time, I kind of just want to put that thing as in like a value member of window, but let's go ahead and do this. We'll make it an own footer. Or since this thing will be part owned by JavaScript, well, this is a bit tricky because I guess somebody could go and hold on to this thing from JavaScript. Like if you did something like X is performance, then now you have the performance object in X, which will keep it alive, even if this window would navigate away to somewhere else. If you retain this somehow, we need to respect that. So I think actually it's a requirement that any C++ object that we wrap in a JavaScript wrapper has to have ref and unref functions on it, which is how reference counting is implemented from the garbage collected side of things. Because the garbage collected objects will ref and unref the C++ objects to make sure that they stay alive. So either we can inherit from ref counted, or I don't particularly feel like I want this thing to be ref counted separately from window because it doesn't seem useful. So I think we'll do a forwarding ref count instead. So we'll do something like this. And we will we'll forward the ref count to the DOM window. And then they will keep the DOM window alive, which will keep this thing alive indirectly. I think that'll be good. Yeah, that'll work. But then we just need to keep track of the DOM window here. So DOM window, and there we go. Let's make that explicit. And performance this. So we could even make it a non-null ref putter because it's never going to be, or non-null on putter because it's never going to be null. That's fine, but we need to include that guy. All right, so there we go with that. So what happens if we try to build this? Let's see. Oh, forgot to update the constructor here. And of course, the implementations of ref and unref. Performance does not name it type. Oh yeah, right. So we need to teach the wrapper generator about this new namespace that I've added. Because the wrapper generator is not super clever about namespaces yet. High resolution time. Yeah, this is reminding me that I need to do more work on the wrapper generator and the IDL parser. But we'll get there. What are we missing? Casting a DOM event target. Oh, right. Oh, we forgot about that whole thing. Okay, so it needs to inherit from event target. Event target. I forgot all about that. An event target is this. Right. Okay. Well. DOM event target. Don't have to tell me twice. Event target. Oopsie doopsie. Here we go. And abstract because we need. Wait, why is this an event target anyway? Oh, it has a resource timing buffer full event? Okay, sure, fine. So it needs to implement dispatch event, create wrapper, Ref event target on ref event target. Okay. Wait, who uses these? I forget. Oh, he forwards here. Okay, okay, okay. Okay. That's fine. Event target takes a script execution context. That would be the window document. I think that's how we will do that. Findings, script execution context. Cannot convert incomplete type DOM document. Okay, because we can't see document, right? And then okay. But do we need the window then? I guess we'll keep that. Okay, but then we don't need these guys. And instead we need whatever the other two were. Dispatch event. Create wrapper. Event target wrapper, right. Event, okay, so how do we implement those then? Let's see. So dispatch event, I forget why that is virtual. Let's go and see what other implementations do. Create wrapper. So what does Node do? It just wraps himself. Okay, all right. So we'll just wrap this. And there's no wrap because we need to include bindings wrapper. Actually, I guess what we need to include is performance wrapper. And high resolution time, let's see. Using wrapper type is bindings performance wrapper. I think that's what we want to do. Then we'll just add that here. To the forward declarations. All right, so it's been a while since I made some new bindings from scratch, so this is a good exercise. We don't have a wrap overload. Performance wrapper. Why don't we have a wrap overload? Here's a wrap. This is the one that we want to call. And I'm in performance wrapper.h. Do I have to call bindings wrap? Yeah. That makes more sense. And then for dispatch event, I think it's just a matter of calling event dispatcher. Yeah, we just want to do this. I'm not sure this needs to be virtualized. I think virtualization of event dispatch is currently kind of a hack, just because we didn't we didn't implement full event bubbling yet, so we kind of hack it so that we can customize the behavior in Node, but ideally these kind of things would not be necessary because they're like obviously very mechanical things, right? Let's see. We need to see DOM event, he says. Performance. Okay, so we need to inherit some more stuff here. We need to inherit from bindings wrappable. And I guess then we need to be able to see that. So, okay, it built, finally. Let's see if we can talk to this thing. Window performance. Okay, that didn't show up because we never added it to the window object. So let's go ahead and do that. So define I guess we can just define property. I mean, wait, what do we want to do here? What does document getter do? There's wraps. Yeah, that's what we kind of want to do. So performance, and then we'll add a performance getter. I don't have a setter for that. I don't know if you want to be able to set that. Okay, and then the performance getter will simply wrap the impl performance. And to see the wrap overload, we need to include performance wrapper. Okay. Wow, this is, I can tell that today is like it's like we're not really on the surface of programming this engine today. Like it's pretty deep into things, but maybe that's still okay. Okay, window performance, we have it. And there is a now. Let's see what it returns. That is a native function, sure. If I call that, we die. Oh, because I forgot to start the elapsed timer. Wait, what happened here? Performance now. Oh, right. If I just type that, it's a function, yeah. Presumably it has some native code. Yeah, you can't see the thing. All right, so we need to start that timer when the performance object is constructed. So we'll just start it right here, timer start. Okay, look at that, boom. We have an incrementing timer. That's pretty cool. So that was a whole lot of boilerplate action just to get that thing working. So what do we have here? We're adding the performance property to the window object, sure, which is implemented as a native getter function here. Okay, we're just declaring that getter. Build system stuff. Here's the bindings generator change. That's not so much, just making sure that we check in that new directory. Okay, and then in the window object, we now construct a performance object. So every window object always has a performance object. that seems fine. Like we don't need to lazily construct that. And then here are some forward declaration changes, and then all the new stuff in this directory, of course. So let's see. So here's the new performance object in C++. Very, very bare bones event target subclass, which forwards its he forwards the refs to window at the same time. It's like, why do we need to do that? I'm not sure. I guess because we need the window to stay alive for this thing to stay alive, because this thing doesn't have its own lifetime management. It's completely dependent on the lifetime of Windows, so we have to forward the lifetime extension requests to window, which is what we do here. Okay, so that makes sense. And then these are just things we had to implement because we're subclassing event target. They're just the most generic possible implementations. Okay, and then the performance object header here. Nothing special about that. And the IDL definition. So extremely simple. I think that's good. So let's go ahead and commit this. Actually, hold on. Or no, let's go ahead and commit it. But add implement performance.now. This patch adds basic, introduces the high resolution time namespace, which is home to the performance object found via window.performance, exposed via window.performance. Performance.now is currently the only function, and it returns the milliseconds since the window object was constructed. Okay, cool. So what other APIs did we have on that thing anyway? So we had performance.time origin. So time origin is a DOM high-res timestamp, so another double, representing the time origin timestamp for the relevant global object. So presumably it's the high resolution time value at which time origin is 0. So like it's when we started the clock, basically, in whatever timestamp value space this is. So we can actually see it here, yeah. So it's some like big number. Presumably that's Unix timestamp. I don't know what I expected. I mean, yeah, actually we can see that it started with 16, which Unix timestamps recently flipped over to 16. What is it? That? Yeah, we can see that it's a Unix timestamp. So let's just go ahead and expose that. So elapsed timer, maybe he can just expose an origin. Origin time, maybe something like that. tvsec. Actually, why not expose the start time? It's actually called start time. But start feels so imperative in this context, so I'm going to call it origin time for some reason. Yeah, I like that better, so let's call it origin time. Okay. So there we go. Yes, yes, and yes. Core. Expose. Core elapse time. Okay, and then we'll use that to implement the, let's see, read-only attribute double origin time. That was the spec, right? Time origin. Okay, my bad. Read-only attribute double time origin. Okay, so that becomes let's just give you the timer origin time, return origin TV sec times 1000 plus origin TV usec divided by 1000, something like that. And a little parenthesization for clarity. Performance now, that's the function. If we call it, we get that. And if we call time origin, I don't think I did that right. So, wait, how did I mess that up? Origin time is the origin time. Sure. What? Origin. Oh, let's use debug F, new hotness. Let's see what these digits that we're working with are. One. Well, that doesn't seem right. What's going on with that? TV sec is now spec TV sec. How is that 1? Oh, it's a 64-bit number? Is that a problem? I am so confused. Let me just triple double check here what's going on. I feel like like it's almost like the time from when I call this API the first time. If I wait a bit. What? What? Clock monotonic, sure. So it contains a monotonic timestamp. Say elapsed, let's see. What on earth is in this thing? I'm so confused right now. This might get really noisy, actually. Because, like, we're not the only ones using an elapsed timer. It might get extremely noisy. Oh, maybe it's not so bad. Oh, wait. Oh, the monotonic timer starts at 0. So it's normal. It's just the uptime of the machine, right? Clock monotonic is the wall time since some arbitrary point in the past. Right, so yeah. I'm just confusing myself. So it's fine for this thing to be based on the uptime. I'm pretty sure. Time origin, timestamp. Time origin is let's see, monotonic clock. Yeah, I think it's okay for this thing to not be the Unix timestamp. It's just me getting confused here, so this is fine. Everything is behaving as it should. I just got myself confused because we're using the monotonic clock, and it starts out at 0. So everything was working correctly. Web implement performance time origin. This is the this is the origin timestamp of a monotonic clock used of the same monotonic clock used for the performance.now timestamp. Got a little confused while implementing this since the numbers are very low. That's because it uses the clock monotonic system clock, which we start counting from 0 at boom. Alright, so that's pretty cool. Maybe we could put something on our test page for this. Like when you load this page up, it could show some little text here like, oh, this page loaded in that many milliseconds or something. Let's see. Welcome. This page loaded in. Let's see. Load time. MS. And then, see, we have welcome.js here, sure. And then I guess we can put a script down here. It was called load time. So performance.now is probably what we want to put there then. So inner HTML is performance.now. Is it that simple? This page loaded in 13 milliseconds. Wow, look at him. That feels like a long time. But we are not faster here, so that's pretty cool. But we should colorize that thing a little bit, just because why not? So we'll put a color. How about yellow? Yellow is very cool. Oh wait, load time. Yes. Very nifty. Okay, let's test it out in the multi-process mode. Works fine here as well, no problems. Very cool. Okay, so I think this is going to be it for today's video. So if you made it this far, then I thank you for watching, for hanging out. And I hope that you saw something interesting today. I feel like it got like a little bit esoteric with the implementation of this object, but hopefully it was okay to follow along. And it's good to add some more of these very commonly used web APIs, because there are a whole lot of them that we're going to have to get through to make web pages work out in the wild. But one step at a time, and we'll get there. Anyways, thanks for hanging out, and I'll see you next time. Bye.